This lesson is about esters, and we need to know about both the structure and the formation of esters. Okay, so we're going to start by looking at what esters actually are. So esters are another example, and actually our final example, of a homologous series, Okay, we've seen this phrase a couple of times now. Okay, remember that there are 4 things that a homologous series have in common. A homologous series is a group of molecules which have all 4 of these things in common. Pause the video now. See if you can think of all 4 things that a homologous series has in common. You need to be able to know at least 3 of these out of the 4. Pause the video now and have a go. Okay, a homologous series is a group of molecules which have similar structures to each other. They have the same general formula. They have the same similar properties to each other, and they react in the same way. So they've got similar structures, similar properties, the same general formula, and they all react in the same way. Okay, so there are 5 different homologous series which you should now, with the addition of esters, know the names of. So esters is one of them. There are 4 others. Pause the video now and see if you can name those 5 different homologous series. Okay, they are alkanes, alkenes, alcohols, carboxylic acids, and esters. So within each of those groups, all of the alkanes have got similar structures, the same general formula, the similar properties, and they react the same way. Alkenes all have similar structures, same general formula, similar properties, and react in the same way, and so on. Okay, they're different from each other, so alkanes are different from alkenes. All the alkanes are similar to each other. All the alkenes are similar to each other, and so on. Okay, esters look a little bit like carboxylic acids do. However, instead of the oxygen, the second one, being bonded to a hydrogen, it's bonded to another carbon. So this is an example of a carboxylic acid, okay, where the second O is bonded to a hydrogen atom. In an ester, okay, the oxygen, instead of being bonded to a hydrogen, is bonded to another carbon. And remember, because the carbon has to form 4 bonds, there'll be some hydrogens on that carbon as well. Okay, so that's the difference between an ester and a carboxylic acid. When we look at a carboxylic acid, it's got an H attached to the oxygen. And when we look at an ester, it's got a carbon and some hydrogens attached to that second oxygen. If it's in a diagram, it's nice and easy to spot because you're just looking at the diagram and you're looking at that singly bonded to the carbon, oxygen, and you're looking at what's attached to it. If it's written out as a structural formula, so like this, CH3 is the first thing, and then COOH for the carboxylic acid, then you'll be able to see that COOH, if it's got an H on the end, that tells you it's a carboxylic acid. Whereas for the ester, the first thing is the carbon with the 3 hydrogens attached to it. Then I've got a carbon with 2 oxygens attached to it, followed by another carbon with 3 hydrogens. Okay, so you can see the difference there. That went wrong. Okay, where it's got the COOH O, but there's no H attached. This time it's the CH3, which is attached to it. Okay, so you should be able to identify an ester based on either its diagram or based on its structural formula by looking and seeing what's attached to that second oxygen. If it's an H, then it's a carboxylic acid. If it's a carbon or multiple carbons, then it must be an ester. Okay, there are lots and lots of different types of esters. You don't need to worry about the names of these esters at the moment. I'm just showing you the diagrams so that you can see the key part here. Okay, so if we look, we can see that after the C double bond O, there's always going to be carbons attached to that second oxygen in every single case. Sometimes it's more carbons, sometimes it's less. It doesn't matter how many carbons there are. You just need to make sure that all of those carbons have 4 bonds and the structure will work. So you can see there the key parts that all of them have got in them are that that's singly bonded to the carbon oxygen is always bonded to another carbon. They're all exactly the same in that respect. Okay, esters are made from the reaction of a carboxylic acid and an alcohol. So if you take a carboxylic acid and an alcohol and you react them together, then they form an ester. The catalyst for this process is sulfuric acid. So you must have sulfuric acid present, otherwise the reaction will be too slow at room temperature and it won't really happen. Okay, the type of reaction is called a condensation reaction. And that's because you get water produced as well as the product of an ester. So when you mix a carboxylic acid and an alcohol and you add a sulfuric acid catalyst, you're going to get an ester and you're going to get water. So the general reaction would be carboxylic acid plus alcohol in the presence of a sulfuric acid catalyst will give you an ester and water. Okay, when you're naming an ester, whichever alcohol you are using is going to come first in the name. So it will always start with this structure, something -ile, and the something comes from which alcohol you are using. Okay, so if you're using ethanol, you will get ethyl something. If you're using methanol, it will be methyl something. If you're using propanol, it will be propyl something. And if you're using butanol, it will be butyl something. The second part of the name comes from the acid, and it will always end in -08. So if you're using propanoic acid, propan-08. If you're using butanoic acid, butan-08. And if you're using ethanoic acid, ethan-08. Okay, so you can see there how we would call the esters made from these combinations. If you're using ethanol and propanoic acid, you would get ethyl propanoate, methanol and butanoic acid, methyl butanoate. An example of an ester which you really need to know, absolutely critical for GCSE, is ethyl ethanoate. Okay, this is the most common example that's used at GCSE level. And from what we did a minute ago, you should be able to predict which alcohol and which carboxylic acid ethyl ethanoate is made from. Okay, so remember the first part of the name, the ethyl bit, comes from the alcohol. Okay, so if it starts with eth, that means that the corresponding alcohol must also start with eth. So it's ethanol. And for ethanoate, that part comes from the acid, so that will come from ethanoic acid. Okay, so those are the reactants. And if I draw those out, ethanol, 2 carbons, and it's an alcohol, so it's got an OH in it. And then all of my carbons need 4 bonds, so I'm just going to complete the rest with hydrogen. And then ethanoic acid, C, double bond O, OH. It's ethanoic, so 2 carbons altogether. And then this carbon on the right needs 4 bonds, so I'm going to complete it with hydrogens. Okay, so that's my ethanol and my ethanoic acid, and I'm going to add those 2 things together. And what is going to happen when I do that is that this hydrogen and this OH are going to combine together. Remember that I told you the other product of this reaction is water. Well, that's how the water is going to be made. The H of one of them and the OH of the other one are going to leave together as water. Okay. Now we're going to have a problem when that happens because my atoms are not going to have enough bonds. So if I draw what my ethanol will look like afterwards, okay, my oxygen has only got 1 bond, which isn't allowed. Oxygen must always have 2 bonds. And if I draw the ethanoic acid after the OH is left, then my carbon now only has 3 bonds there, which also isn't allowed. Carbon needs to have 4 bonds. And so what's going to happen is that the oxygen is going to bond to the carbon there. So now the oxygen has 2 bonds, great, and the carbon has 4 bonds, fine. So that is the molecule. This molecule here is ethyl ethanoate. Okay, so that's the reaction. Okay, you need to know that ethanol and ethanoic acid react together to make ethyl ethanoate. You need to be able to draw ethyl ethanoate, and you need to be able to recognize ethyl ethanoate if the drawing is given to you. You should also know that water is the side product of this reaction, and you should be able to draw this diagram showing how ethanol and ethanoic acid react together to make ethyl ethanoate. You probably won't be asked to do the reaction for any of the ones more complicated than ethyl ethanoate, but you should know how to name them like this. So you should know how to do the name of the different esters based if they give you the alcohol and the carboxylic acid. Okay? If you do want to stretch yourself and to push yourself all the way to what you maximum level of level 9, then maybe have a go at the extension task on this document as well, which asks you to draw the esters formed from different combinations. Okay, that will prepare you very well for IB level chemistry if you can do that. Okay, so that's what you need to know about esters. Please continue down the Google Doc, answer the questions given, and if you've got any questions about this, send them to me on Google Classroom.